Welcome to SanfordFlipMath. This is Algebra 2, working through the SpringBoard textbook. We are working on piecewise functions. We already worked a little bit on piecewise functions, and just a reminder that piecewise functions are, shockingly enough, functions that are pieces. Yep, I know it's true. It's exciting. Basically, again, there are separate equations that are used for specific x values. We did a couple of examples, few examples last time. Here were some examples. We're going to do really just two more examples together here, and one of them is going to be, dare I say it, quote, SpringBoardy. Okay, all right, so we're going to do a little graphing, and again, the suggestion is to really graph these basically one at a time, and then kind of erase them down to just the parts that we want to keep. So for instance, this is just y equals 2x plus 3. And most of you are very comfy graphing this, I would hope, with a y-intercept of 3 and a slope of 2. And so it's going to look something like these. Okay, and sorry, my head was in the way. You can't see that, but that's what happened. And something like that. That's looking kind of scary, but you get the gist. And what this says is only graph that from -3 to -1. Well, -3, the x value -3 is right here, and the x value -1 is right here. So I'm going to get rid of everything that's not between those two. Okay, and worth noting that at -1 itself, it's not supposed to be included. So here it is. But it is supposed to be included at -3. So again, this is the x value -1. It is the x value -3, not the y values. Okay. We're going to continue on with this joyous endeavor. Well, y equals -1 is an equation that has a slope of 0 and a y-intercept of -1. A little better, there we go. And in other words, it's a horizontal line. So like for instance, here we are, all of the y values on this line are -1. Okay, so if I'm graphing this, I would graph it like that. Now, I'm only really supposed to be graphing this from the x value -1 to the x value 2, which means I'm going to have to do a little bit of erasing. And I will fix my blue line also. I know I made a mess, but I think it's worth it to see really what's going on. Okay. Now, worth also noting, that's a lot of noting, this says or equal to, this says or equal to, so I'm filling in both ends of the red graph. Okay, and one more piece, and that's y equals -x² plus 4. Now, some things to consider here. -x², well, x² is a parabola. The negative part makes it open down because there's a reflection over the x-axis, and this shifts it up 4. Now that's a lot to remember, but it's normally at 0, 0. It starts at 0, 4 because of the shift. It does open down, and it would go something like this. Now I am not going to draw everything over here because I don't want to erase everything, but remember that this is only going from the x value 2 to the x value 4. Now, just to be really clear here, if I do put the x value 4 actually into the equation, I really get -12. Okay, so what I'm going to do is go down to that y value. So really there's an ordered pair for -12 because I just want to identify exactly where this really goes. So here's 2, 4, 6, 8, 10, 12. So I'm really supposed to be here, and I'm really supposed to be here on the x-axis. Okay, so let's see if I can get the rest of this going. Oh no, that was the part I wanted to keep. That's all good. Okay, there's the part I want to keep. The rest of it up here goes. Okay, now let's deal with endpoints because that's the other concern. It says less than and less than. So there's no equal there. So that means both ends are supposed to be open. Okay, so let me clean that up. That's open and open, and we're done. So I'm trying to do a little color coordinating here. So if you're able to identify the colors, then that's useful. Okay, so we had y equals negative x squared plus 4 in green that time. So that's part of a parabola opening down. All right, so again, the short version is graph each equation separately but on the same axes, and then kind of narrow it down to just the values you're supposed to do for that graph, that function, that piece. All right, here comes, dare I say it, Springboard in quotes. Springboard is all about word problems, about context, about real life. So here's a situation. It says parking garage charges different rates at different lengths of stay. For parking up to 2 hours, the rate is $4 an hour. For hours more than 2 and up to 4, the rate's $3 per hour. Anything after that, $2 per hour. Okay. Now the thing that's going to be tricky here is that it really does change. So like for the first 2 hours, you're paying a different rate. Okay, so this is what it's going to look like. We're going to do f of x equals, or you can put y equals if you wish. But we have 3 different conditions, and each of these conditions has its own little equation. So for parking up to 2 hours, the rate is $4 per hour. So it means we're going to pay $4 times the number of hours. But this is only up to 2 hours. So that means we're really only talking about x is less than or equal to 2. Now, I left a lot of space there because I need you to think about the fact that, are we really going to have negative hours? Probably not. So we really are going to talk about 0, and we're going to have to make a choice here. If you put less than, so 0 is less than x, and then we're not including 0, well, I think that would be okay, because we're not going to pay anything if we're talking about parking for 0 hours. Now, some of you might argue, well, how about we put the or equal to, because then 4 times 0 for that amount of time is going to be 0 anyway. So can I just say that I'm okay either way? If we leave that off, then we aren't going to include 0 time. Okay, that's fine, because there won't be a charge. Or if you want to include 0 time, you can put it there. So I'm going to let you decide. Okay. All right, next part. It says for hours more than 2 and less than and up to 4. Now, I think up to includes the 4. So I'm going to write that, and I'm using the wrong color, so I'm going to switch that because I'm trying to color coordinate with what's in the wordage. Okay, better, sorry. Okay, so that's more than 2 and up to 4. Okay, it says $3 per hour. Well, I got a little bit of an issue here, because if I say this, it's really not $3 an hour for the first 2 hours. Okay, so let me show you what I mean. If I park for 0 hours, I'm going to pay 0. If I park for 1 hour, I'm going to pay $4. If I park for 2 hours, I'm going to pay $8. If I park for 3 hours, okay, now it's a little more complicated, because what I actually have to do is pay the $8 for the first 2 plus $3 for the third. So that's really $11. So it gets a little more complicated in the fact that what I have to do is do $3 times the number of hours, but only the number of hours after the first 2. So how can we account for that? Well, I think what we have to do is something like x minus 2. Okay, so $3 an hour for the hours after the first 2. Well, how do you account for the first 2 hours then? Well, I think what you need to do is add on the money for the first 2 hours. Just tack it on. Okay, so think about what that says, and maybe you want to pause for a second and make sense out of that, but again, that x minus 2 is because we're talking about the number of hours after the first 2 hours. So for 3 hours, it'd be 1 more hour. For 4 hours, it'd be 2 more hours. For 5 hours, it'd be 3 more hours, you know, that kind of thing. Okay, and that plus 8, I actually wrote that in red because it's really came from the first 2 hours. Okay, all right, one more little chunk, and this one's going to be similar because what we're going to do is do $2 per hour, but this time it's only for the hours after 4, so more than 4 hours. Okay, so what we're going to do is more than 4 hours. So how many hours are more than 4 hours? Well, I guess it's the 2 times x minus 4 because x is the number of hours at that point. Now, the other question is, how much do we add on? Well, what I would do is come over here and play with my little table again. Okay, so 4 hours should be, okay, so if I do 3 times 4 minus 2 plus 8, so this is 3 times 2 plus 8, would be 6 plus 8, or 14. So this should be $14. Okay, so again, the $14 is from the first 4 hours. The first 4 hours came from the first 2 hours. 2 times 4 is 8. Plus the next 2 hours. 3 times 2 is 6. So that's 14. And that accounts for the first money that we spend. And then the 2 times x minus 4. So like, for instance, if I parked for 6 hours, I'd be saying 2 times 6 minus 4 plus 14. If I was parking for 6 hours, that's how much money I would spend, which is 2 times 2, so $18. Okay. So it's like the longer you park, the less each hour costs. However, you still have to pay the higher rate for the early times. Okay. All right, so it says write a piecewise function for the charges. That's what we just did. This is a piecewise function for the charges. Now, if you wanted to use C for charges or cost, you could, or Y equals just because you like Y, or maybe you want, instead of X's, you want T because it's about time, or H because it's hours. You know, any of that is fine. Okay. All right, well, we're going to graph this thing now. Okay, so I have it all set up and ready to go. Ta-da, here it is. Okay, now you need to make a decision on how you want to graph, how you want to work with these equations, because these are not in really cute form to do this. So, okay, now let me remember what colors I used. I used red, green, blue. Okay, so red, green, blue. Okay, so again, I'm color coordinating just for you. Okay, isn't that sweet of me? All right, so y equals 4x. Well, that one's not so hard. Y equals 4x, so it has a y-intercept of 0, 0. Now, I have no negative values, which is why I have my graph set up for the first quadrant. Now, I do know I need to get up into like 14 and things like that. So I think what I'd like to do is number the x-axis by 1s. Okay, so I mean, that's not anything new. So, okay, please understand I just numbered by 1s. Okay, think about why that's true. On the y-axis, however, I think I'd rather number by 2s. So I'm going to call this 2, 4, 6, 8. Okay, so in labeling, this is going to be my number of hours, and this is going to be the money, and this is cost to park. Okay, so I'm doing all my labeling like I'm supposed to. Good job, Mr. Sanford. Thank you. All right, 4x. So I'm going to go up 4 and over 1. I'm going to go up 4 and over 1, up 4 and over 1. Yes, that looks like 2, but remember that we numbered, that was terrible. Remember that we are numbering by 2s. So this is actually appropriate. Okay, something like that. Okay, now let's think about this. That little I just did on the end, does that make sense? I don't think so. And this is only going to go to the x value 4. Okay, y only to the x value 4. I'm sorry, this is only going to go to the x value 2. Okay, y only to the x value 2 because that says 2. Okay, and do I include those points? Do I fill them in? I fill in this one for sure. The 0, 0 depends on what you said right here. I mean, if you want to leave that less than, then don't fill in 0. If you want to leave that less than or equal to, fill in the 0. Okay, we talked about that a little bit before. Okay. All right, next up, how are we going to graph this? Okay, well, you have to make a decision. This, one way to think about this is this started out as y equals x, then there was a vertical stretch of 3, and it shifted right 2 and up 8. So the place where this used to cross at 0, 0 shifted right 2 and up 8. So one way to do this graph is to actually go to 2, 8. Don't fill it in like I just did, but it really won't matter. And then do slope of 3 from there. Okay, so slope 3 would mean up 1.5 squares and over 1. Now, I already know that I'm not going to draw the left, going to the left from there. Because the other function takes over. Okay, now let's be technical for just a hot second here. This was filled in. Technically, the green would not be filled in on the left side, but do understand that once this thing's filled in, it doesn't matter what color it is anymore, because it's all technically part of the same function. Okay, and we're going to only draw this to 4. Okay, so the x value 4, because it says to 4. Okay, and just to be real clear here, I want to double check my ordered pairs here, but I think I'm supposed to be here. So, like for instance, if I put in the value 4, the y value, so I'm going into this equation, 3 times 4 minus 2 is 2, plus 8 is that 14 that I saw that number before. So here's 8, 10, 12, 14. Yeah, so I need to be here. All right, so I'm gonna fix my line because I was a little bit off in terms of drawing it, okay? And I do include the other point. Now these look really similar, but remember this slope, I'm just going to put a little note on here so we can kind of identify the difference. This slope was 4, that slope is 3. You wouldn't have to make that notation, but you know, if I were grading this, I'd be looking for those points very, very carefully. Those points where the thing turns, starts, stops, and stuff need to be like spot on. Okay. All right, we got one more to go, and then we're out of here. Oh, before I do, sorry, I know you were really excited. Some of you I know would rather distribute this okay, and then simplify it. And you can absolutely do that. You know, you would start at 2, you'd go up 3 over 1, up 3 over 1, etc. Okay, and then it should match up with the same graph. Okay. Oh, no, that's it. Up 3 over 1, up 3 over 1. There I am. There I am. All right, cool. I was counting wrong a second ago. So another way to graph this would be to graph y equals 3x plus 2, but you remember you'd have to get rid of the part between the 0 and 2. All right, last little chunk in blue. Okay, so we're going to do y equals 2 times x minus 4 plus 14. Now again, I think the easiest thing to do is start at 414 because it shifted 4 and up 14 from what y equals x used to look like. It got a vertical stretch of 2, so the slope is steeper, and shifted right 4 and up 14. Well, 414 is this point right here. Okay. And then I'm going to go up 2. Okay, remember 2 is 1 square over 1, up 2 over 1, up 2 over 1. And this part goes forever. So if you wanted to park for a weekend, you'd be on that part of the graph. Okay. Again, it doesn't really matter whether this point is filled in blue or not because it was filled in with green, so it's filled in. Okay, and then just to again be clear here, the slope here is actually 2. Okay. All right, so I think really the hard part of that problem was this. That takes practice, and that's the hardest thing to give you practice on. So I'm going to use the ugly T word. You definitely have to think when you're doing that. And then this part is just like what we've been doing for the for the first part of this video and the last video. So, all right, well, thank you for hanging with me. I was hoping for shorter since technically we only did 2 problems, but 20 minutes is still not bad for a Sanford Flip Math. Thank you for watching. We'll see you in class. Bye.